All right then, good afternoon everyone. Yeah, I'm going to get started then. Some people might keep joining us, but that's cool. First thing, I'm not feeling particularly well, so if I need to just take a couple of minutes to myself and sit down, don't panic. Feeling kind of a bit spaced out today, but I am going to be talking to you about refactoring CSS. It's quite a big talk, quite a lot of slides to get through. We'll start with some fairly philosophical views on refactoring, proving the business case for refactoring, perhaps proving the business case for not refactoring. The talk will be dealing with CSS specifically, but you can apply some of the principles to other programming languages. So you can potentially get some mileage out of that. After we've looked at the philosophical bits, the kind of proving the business case for refactoring, we will look at some specific tips to help us rewriting legacy or old or sprawling CSS projects. Quick hello from me then. My name's Harry. I'm a consultant front-end developer from the north of England. And being a consultant, I spend a lot of my time traveling to different clients, seeing a lot of different projects. I work with CSS architecture and performance, and I tend to deal with this kind of stuff at scale. So large companies, large code bases, which are going to be quite old, lots of developers touching them, lots of legacy, lots of old systems, lots of badly maintained systems. So as you can imagine, it requires quite a lot of refactoring work. A lot of my job is refactoring CSS, but unfortunately, I cannot stand refactoring CSS. It's awful. Has anybody refactored some CSS before? Yeah, about half of us. Keep your hands up if you enjoyed that experience. Yeah, exactly. So refactoring CSS it's not a particularly fun thing to do. CSS, it's not a very nice language. It operates completely globally. We can't write tests for it. So if we're refactoring, we don't really know if we're introducing regressions by accident. Everything operates completely globally. So you try and refactor your nav, and for some reason the contact form falls over. So these are the kind of things we deal with when we refactor CSS. So hopefully after this talk, we'll have a slightly better grasp of how to make that process not enjoyable. I can't promise it will become enjoyable, but potentially a little bit easier, a little bit simpler. So we'll look at some specific techniques to tackle refactoring our CSS. Before we get into it, we should probably get a definition, a shared definition. What do we talk about when we talk about refactoring? There's a really nice definition from a guy called Martin Fowler who describes refactoring as the process of changing a software system in such a way that it does not alter the external behavior of the code, but does improve its internal structure. So just reading this definition, the first thing I'm getting here is that this isn't for our users. This is obviously a business decision. It affects developers, development teams. And it's a way of keeping our code nice. So the fact that by definition it doesn't change the external behavior means that this isn't a customer-facing decision. This is a thing that the business or the development team would decide to do. However, I would argue that after enough time, the knock-on effects of refactoring do indirectly benefit users. A nicely refactored code base, CSS or otherwise, means that it's probably quite consistent. It's not very prone to bugs or inconsistencies. If we've got a nicely refactored code base, we can probably add features quite easily. It's going to be quite easy to get new features in front of customers much more quickly. So the business case for refactoring can eventually and does touch on sort of customer and user-facing things, right? When we look at the business case for refactoring, we ultimately have to consider that it will improve the product for the customer as well, not just the developers. To my mind, and certainly for the purposes of this talk, I think there are three main kinds of refactoring. The first is what I call as-you-go refactoring. This is the stuff we should be doing all the time. We may have hacked together a feature, hard-coded some things, got proof of concept together, but before we submit that for a merge or before we put that live, obviously we're going to tidy it up, we're going to document it, we're going to dry it out, we're going to make better use of variables and functions and mix-ins from the wider SaaS project or whatever we're using. So this is the kind of tidying up that we would expect to be doing every single day. If we don't keep on top of this tidying up work, we can step into the second type of refactoring, which is technical debt. We'll talk a little more about technical debt in a few slides' time, but technical debt is basically we did what we could in the time we had available or with the resources and knowledge we had available, but now we've realized that this is a problem, this has become problematic, and we have to set aside some time to go back and fix this. This was fine, this was acceptable, this was a sort of considered decision at the time, but now we know better, we are going to go back and fix things. And finally, we have the rewrite or overhaul. And this is the most expensive, sort of drastic measure we could take. This is basically things have got so unwieldy, so hard to maintain, that the only real solution we have left is just to tear it down and start again. This is very expensive, and we want to try and avoid this kind of refactoring. So these are the stages we are likely to go through. And I found that we encounter these stages, or we're more likely to encounter them the further into the project we get. And the size and scale or the cost of these refactoring tasks increases as we progress through them. As you go refactoring, we're looking at minutes to hours, right? Just tidying up a feature, documenting it, making better use of sort of the framework or whatever we're looking at. This is relatively cheap, and it's a good way of preventing us moving further down this line. If we don't keep on top of this, if we do end up accruing lots of technical debt, paying that technical debt off, I would say we're looking around days to weeks. Re-implementing a feature or paying off a substantial amount of technical debt is going to be relatively more expensive than just as you go refactoring. So this is why we need to try and catch things as soon as possible. Finally, if we unfortunately don't catch things at technical debt stage, if we do not get given the time from our managers to pay back our technical debt, we approach the rewrite and overhaul stage, and this is looking at sort of weeks to months. And the reason rewrites and overhauls are so bad is, well, one, it kind of reflects badly on the dev team, right? Have you ever had to tell a manager that we need to slow down and rebuild this, and they think, well, why did you do it wrong in the first place? And it's like, it's not my fault, you just didn't give us time to tidy up the technical debt. So rewrites and overhauls usually, not always, but usually end up reflecting badly on the development team, which I think is a very unfortunate thing to happen. But the main problem with a rewrite and overhaul is the sheer expense. Let's say it takes 6 months to rebuild your application. Somebody has to find the budget, the funding for a 6-month rewrite project, so already we have that cost. But then that brings with it the 6-month opportunity cost. That's 6 months we could have been building new features, but now we're actually spending it just getting back to feature parity. I've been involved in quite a few rewrites in my sort of career, and it always feels like a real shame. It's nice to get a fresh start, but from like a business perspective, having to tear something down after just a couple of years and rebuild it feels like a really expensive kind of approach to take. So I'm always a fan of making the business case for paying back technical debt, just to try and avoid being on yet another rewrite. And the problem with rewrites as well is you start off with the best of intentions. It's like, we'll do it right this time we get it right. And of course, we never do, because as soon as you finish a project, the moment you finish a project, you already think of 10 ways you would have done it differently, right? So it's really difficult to kind of go through this continuous process. We're quite a technical audience, so I'm guessing who's heard of technical debt before? Yeah, all of us. I actually gave this talk once, and about 3 hands went up. It was quite interesting. So yeah, we all know what technical debt is. A debt means, this is actually, the article linked here is a fantastic introduction to technical debt for both technical and non-technical people. But a debt means that you acquired something now for a long-term financial burden. This burden is not just about repaying what you've got, there is also interest involved. It means that even if you pay your debt timely, you'll pay more than you took. And if you don't, your debt will keep increasing. If you ignore a debt long enough, it will become unpayable and you will go bankrupt. I think the tech debt analogy works amazingly, especially for non-technical people. But one thing that a lot of people don't understand, it's certainly in sort of my client work, I've realized that a lot of people assume that all bad code is technical debt. And it's not at all. Technical debt is a very different thing to bad code. It could be bad code as well, but technical debt is a conscious decision. Technical debt is a conscious decision to take a shortcut now in exchange for repaying something later. I've had a lot of clients email me saying, oh, we've managed to get a lot of technical debt we'd like to pay back. And I look at their project and their code, and I'm like, that's not technical debt. You just don't have very good developers. It's really important to be able to tell the difference between what technical debt is and what bad code is, because technical debt is not a bad thing. It's a conscious business decision in many ways that we know there is a better way to do this, but to deliver a feature on time, we're going to take the shortcut. So we're going to incur some of it. It's a fact. It's pretty much inevitable that every project we work on will have some technical debt in there. That's fine. We should be able to live with that, but what we have to also acknowledge is that it's vitally important to make the repayments, sort of make the business case to do so. A lot of people forget as well that the technical debt analogy, the debt analogy, does include interest. Doing something right or correctly now might take 2 days. Hacking it might take half a day. Doing it correctly in 6 months' time is going to take you 3 days. So it's ultimately the most expensive version because you've got the half day and the 3 days in the future. So technical debt, the longer you leave it, the more expensive it gets. So it's very important to be able to make and prove the business case to your managers or your client, your customers, to get the time and the budget for this refactoring work. So let's look at some examples of what we should refactor and when. My very kind of politician's answer to this would be, we should always be refactoring something. There should always be something we should be tidying up. But of course, that's not really good enough advice. So what I tend to find, especially when I work with clients, is if the projected cost of maintaining something is going to be higher than rewriting it, perhaps invest the time in that rewrite. If you know that something's going to be very laborious, very expensive to maintain, even though that cost is spread out over a long time, sometimes it's worth taking the hit up front and just rewriting. If the current version of something is slowing you down, if something is actually causing you problems, that's not very productive, that's not very future-proof, right? You can't just carry on with your head down in this very unproductive environment. So if the current version of something is showing tangible damage, it's causing you noticeable slowdowns, that's another case in which we should argue for the refactor. But on the flip side, even if we're not experiencing problems right now, there could be a different, new way of doing something. There could be an alternative approach that will actually be better, even better than what we've got now. So it isn't even about if you're being slowed down. It's about if you can implement something that will increase your productivity measurably. An exercise I often go through with clients, and again, we're talking about CSS here, is this kind of thing. This example is adding a theme to a website, right? We've got a website and a customer wants to add their kind of branding to it. We've got an existing code base, and we've got time estimates in the refactored code base. These are how long we think it might take. So a customer gets in touch and says, we want to add a theme to our sort of software as a service platform that you've sold us. And we could hack a theme in there. Perhaps theming was never meant to be a part of the project, but we could hack it in 2 days. And in 2 days' time, the client's happy and we've been paid. But then the next client comes along and says, well, we'd like theming as well. So you can say, well, we can hack a theme on top of a theme. We can do that. And that's going to take another 2 days. But then the third request, that goes up to 2.5, because we're talking about this interest now, a hack on top of a hack on top of a hack. Things are getting messier and messier. So the overall cost of supplying these themes to these customers could be 9 days, whereas on the flip side, we could argue, or we could make the case to our product owner or our client, our customer, well, how about if someone wants a theme, we build it into the framework as a first-class citizen? What if we spend 7 days making theming a first-class citizen, deliver the first theme inside this new framework, and then every subsequent request is a simple case of implementing some different color values, perhaps? We can see here that even though the upfront cost is much higher, the ongoing maintenance cost works out noticeably lower. These are the kind of things that developers have to get used to. Developers, I find, cannot stand making estimates. Developers typically aren't very good at making estimates, but it's something we all have to try and get better at, because it's these kind of numbers that are really valuable to take to the business. Making the business case for this refactoring work is absolutely paramount. The second column, the refactoring, the cost of 7 days, represents technical investment because, of course, investment is the opposite of debt. The technical investment gives us more runway to work faster later on. However, as well as the importance of refactoring, it's also important to recognize when we shouldn't refactor things. There is a business case for not refactoring. If something isn't actually slowing you down, if something isn't making problems or causing problems for your team, it probably isn't the best candidate for a refactor. This slide out of context just looks like terrible advice, so don't tweet a picture of this. The second one, if it's something that can be ignored or avoided, I've worked with clients before where they want to refactor things that they never actually touch. So we'll leave it alone for as long as possible. Try not to invest time up front refactoring something that can just sort of exist happily as it is. If it's something that can be captured by a rewrite later on, I've worked with a lot of clients who they say, oh, we're going to rewrite the platform in 12 months, but in the meantime, we just like to tidy it up and refactor it. Well, don't spend money on me refactoring a code base that you know you're going to tear down in 12 months anyway. Try and squeeze every last drop out of it for as long as you can. And sometimes a rewrite is a better solution. I'm sure we've all inherited a project before that we've tried to refactor, tried to tidy up, and we've just realized that, you know what, it's going to be quicker to start again. Especially with CSS, just rebuilding the feature from scratch is often a quicker solution. Some real examples from work that I've done to try and back these up. I got an email from a client saying, we want to rewrite our CSS onto the BEM naming convention. Anybody who knows me knows that I love BEM. I think BEM's a fantastic naming convention. I think it's a very sort of powerful tool. But I don't think that taking 2 weeks out to refactor your CSS onto a new naming convention is going to pay itself back very quickly. I don't actually think there's a strong business case for just changing your naming convention. If you can prove that there is a business case, if the numbers suggest that, yeah, actually it will make us much more productive over the long term, then your numbers tell you that it's a good idea. But they seldom will do for something as cosmetic as this. Another example, a client emailed me, oh no, this was actually in a meeting. I said, oh, we think the code for this nav is quite ugly. We'd like to refactor the code for this nav. And I looked at the code and they were right, it was ugly. It was disgusting, it was terrible. But before we rolled up our sleeves and started rebuilding it, I asked them a few questions. Is the nav actually causing any problems right now? What problems does it present? And it turned out the nav was completely accessible. It worked in every browser, on every device that it needed to. It was fully responsive. It worked completely fine. So my next question was, okay, well, how often do you have to work with this code? How often do developers get slowed down by working with this nav? And the answer was, well, it's a nav, so every time a user adds a new page to the CMS, it adds to the bottom of the nav and there's zero manual intervention. So it turned out that the nav code wasn't actually slowing anyone down because no one was having to edit it. So my third question was, can we just leave it alone then? We'd be aware that it's bad, but there's no need to spend good money on refactoring something that isn't causing you any problems. There are much more important things to look at. So our eventual kind of decision here was that we shouldn't be refactoring things purely off the back of pride or the fact that, or the thought that we could do it nicer. Working and ugly is better than perfect and not working yet. It was working fine for them. We couldn't justify the spend of days of my time just to rebuild a nav that had really no problems. Okay, moving on to some more kind of practical things then. There's a concept I came up with earlier this year, which I called the refactoring tunnel. And the refactoring tunnel is a metaphor which describes a refactoring task. And the tunnel goes through your project. The length of that tunnel dictates how much of a task you've taken on. The longer the tunnel, the worse it is. And the analogy, kind of the metaphor, goes like this. Day one, you step into the tunnel, and you start refactoring. And behind you, you can see the entrance, you can see the light at the entrance of the tunnel, but you can't see the light at the exit. It's round a corner somewhere. Day two, you carry on refactoring, you step a little further into the tunnel, and behind you, you can still see the light at the entrance. You're aware of how far you've come. But you still can't see the light at the exit. On day 5, you've gone really far into the tunnel, and all of a sudden you can't see the light at the entrance, and nor can you see the light at the exit. And you don't even know where the exit is. And the nav is broken around your feet, like the site's completely ruined around your feet, and you just don't know. You've tried to do a find and replace for all your class names, and that went wrong. And you still don't know, is it 5 more days? Is it 105 more days? And you don't know how much refactoring you've got left to do. And then you just do this. Who's done this before? During a refactoring project, exactly, we've all done it. And this is because we decided to refactor something that ran all the way through our project. A refactoring tunnel represents something with a large surface area or something that touches a lot of the project. Avoid long refactoring tunnels. We need to identify much shorter ones. A long refactoring tunnel could be something like converting all your classes from one naming convention to another, or swapping out all of your icons from PNGs to SVGs, or anything like that, converting all of your Sass to post-CSS. Anything that touches a large amount of the project, anything with a large surface area, is typically going to leave us open to problems. It takes too long, leaves things very messy in the meantime. We end up throwing it away. We get very specific problems like merge conflicts. Can you imagine trying to rename all your classes and then trying to merge that into master? It's going to be a nightmare. And also, the problem with refactoring something that touches the entire code base is that it's really easy to introduce new bugs and regressions by accident, and it's very hard to keep a track of those. Because we can't write proper tests for CSS, it's hard to keep track of any new bugs or regressions we've introduced. So instead, we pick off things with a small, limited, clear scope, short refactoring tunnels, and we do that instead. So what you might do is identify, ultimately, we want to rename all of our classes onto a new naming convention, but what I will do is just refactor the nav today. Then tomorrow I'll refactor something else. Pick off these short little bits of work and get it completed. And then this gives us a really nice sort of decision to make. I mentioned that refactoring is an opportunity cost, which it is. And if you're going to take 2 weeks out to refactor something, that's 2 weeks that you're being paid, not to deliver new features. If you can just refactor something that takes a day and a half, that means after that day and a half, you can get back onto feature work. It means your managers aren't funding refactoring work for a very long time, and you can get right back onto providing sort of immediate value. Or if you have enough time, you can pick something else to refactor. Today we'll do the date picker, for example, and then tomorrow we might do the carousel. Rinse and repeat, and we find that ultimately or eventually the site has refactored itself. By picking off these short, limited bits of work, we can get the bigger task done gradually. When we pick off these refactoring tunnels, it's important to refactor these things in isolation, especially with CSS. We don't want to rebuild features back into a dirty code base. Because CSS operates globally and everything inherits and cascades, we don't want to risk building a feature back into a stale environment. We don't want to lean on CSS that itself is out of date. So fire open CodePen, JS Fiddle, whatever it is you use, and rebuild the feature completely outside of your project. Once we've done that, we port it back in, and we do any tidy up work there. So what we do is we build the best version we can in isolation, then move it back into the project, and any collisions or regressions we tidy up at that point there. For example, the header could be a really good candidate for one component to refactor. And we go off to JS Fiddle, rebuild it exactly how we want, using new naming conventions, whatever we decide to do, and then move it back in. The problem is, though, it's fairly safe to assume that if we just copy and paste new CSS into old CSS, we're going to get some breakages. We're definitely going to get some collisions. That leads me on to this next little tip. Who's heard of all initial? Yeah, only a few of us. All initial is incredible. It effectively stops inheritance. It sets all CSS properties back to their initial value. It's a really good way of progressively working with legacy code because it stops old legacy CSS from leaking into your newly refactored component. I use the word progressive because we do have to come back to browser support in a second, but I'll just show you how it works. Right? We've got this bit of red text down here, and this is red because the paragraph's inside a div, and the div has font weight bold, and body has color red. That's just how CSS works. It's inherited those rules. We've got a bold red bit of text. As soon as we drop all initial in there, it drops back to being black and font weight normal. So all initial effectively stops inheritance. There are some oddities with all initial. Let's say we have gone and refactored that nav. Nav primary, all initial. Nav primary link, all initial. Unfortunately, because we've put all initial on the primary link as well, these two font properties, these font declarations, they will no longer get inherited. This is going to be back to 16 pixels times New Roman. And the way we get around that is just by moving these properties onto the leaf node. We just move them to the end of the DOM tree so that they are applied very last, and we don't reset anything by accident. Yeah, browser support. So actually, browser support is kind of good news, bad news. We've got a lot of green in here. Green is good. But we've got two concerning blobs of red, which is going to mean that we can't really use this as a fix-all solution. We can't use this as a one-stop shop. What that means to me is that I would tend to use all initial as just buying us a little bit more time. Use all initial when we're refactoring CSS. And what it means is that if we do get any regressions that end up unfortunately going live, only a small percentage of our user base will ever see them. It just buys us a little bit more time to tidy things up. The majority of our users will be using a decent browser. They're completely immune to the effect of these regressions. And we can have that little bit longer, that little bit more time to tidy things up in IE. Talking about kind of a last line of defense, defense.css is sort of a micro project that a client and I worked on at the beginning of the year. I was working with a client who had a very specific question. What happens when we need to run refactored code and legacy code completely side by side? That question was asked of me by a company called Sky, who are a large sort of broadcasting company back in the UK. And I actually used to work for Sky full-time about 5 years ago. And I'm back in consulting with them now on a rebuild of their UI toolkit. They've got a new design language. They've got a modernized architecture to deploy it with. So we thought we would rebuild the CSS from the ground up. So we had this new toolkit developed. We had to roll it out very gradually because Sky employ about 30,000 people in the UK. It's a very big company, and we can't just rebuild the site overnight. So what we had to do is pick a candidate, which is always the homepage. Marketing always want to do the homepage first. That's not how CSS works. We did the homepage first, and what we did is we implemented a new toolkit there. The rest of the site was using the old toolkit, but if the homepage project was successful, we would roll the new toolkit out across everything. But now it meant the site was using old and new toolkits. It was like using Bootstrap and Foundation completely in tandem. And as you can imagine, if you try and put old CSS and new CSS together, it doesn't really work particularly nicely. The sky.com domain is running two very, very different CSS frameworks, two completely different UI toolkits. And it had this horrible interface where the collisions between old and new were plentiful and just often confusing. We couldn't get these two things to play very nicely together. So we had a decision, where do we put the fixes for this? Now, we definitely don't want to put the fixes for this in the new CSS. You don't want to start a greenfield project by filling it with hacks for legacy code. So what we decided to do was create a brand new third project. And we called it defense.css. And the idea of defense.css was to smooth that interface so that these two projects could coexist. So defense.css was a whole new open source project. There are a couple of benefits to running it as an open source project, internal open source project. Firstly, it meant that we could crowdsource the bug fixing. The homepage team could implement their fixes and push it upstream. The next team, maybe the sort of help and support team, they could install this dependency and get our fixes, but also anything they fixed, they could contribute back upstream. So the entire company begins crowdsourcing these bug fixes. And the second reason it's nice to have it as an external dependency is that it's a temporary solution. That's famous last words, but it's a temporary solution. As soon as we decommission the old toolkit, we need to be able to decommission defense.css as well. We need to snip that dependency off very, very simply. The CSS in this file is disgusting. It's horrible. It's just kind of type until things work. I've actually worked with front-end developers who seem to employ that technique to their entire career and just type until it works. But this is the one time I'm OK with that. This CSS file is basically brute forcing things, fixing bugs, fixing this like interface between old and new. And we're OK with that. We're happy with this. We don't want this to be good CSS. It just needs to be functional. It needs to work, and it's going to get deleted. I was hoping to show you what's in this file, but I wasn't really clear if it would. I mean, it's really nasty CSS. It's really nasty CSS, and I was worried it may violate the code of conduct. I mean, it is that bad. So what I did is I pixelated it, so you can see a pixelated version. But what you will notice is a bunch of importance, right? This is how bad we're talking. We're just sticking everything and anything in this file to get things working again. This is a very good technique to use if you have to transition from one UI toolkit to another over any amount of time. Next tip, quite a short tip really, RF classes. An RF class is simply whenever you rename a class when you're doing some refactoring work, or anytime you refactor anything at all that has a class involved, just stick an RF hyphen in front of that class name. What this does is it tells the next developer that this has been fixed, this has already been refactored, you don't need to touch it, it's a solved problem. But it also means that we can do things a little more automagically. We could write a selector like this. If a class contains RF hyphen, stick a green border around it. We could hide this behind a config switch in our Sass. And that means that we can get a visual health check, a visual overview of how well the refactoring project's going. Instead of having to look through lines of code to see what's been refactored or checking Jira tickets, we can just turn this on and click through the site. Here we can see that the nav and the content blocks have been refactored. It looks like we've done quite a lot of work here. This represents the work that we've done, and this is also a very good method to use if you want to try and show a non-technical member of the team where you are in your kind of refactoring progress. If you turn this feature switch on and say, look, visit my dev site at like this URL, we're making really good progress. There's lots of green where the refactoring task is nearly finished. So it's a very good visual snapshot of how well or how far into the refactoring task you are. To kind of invert what we're looking at, we could just write a selector like this. Find me every class that is not a class that contains RF and throw a red border around that. Here we can see, if we turn this on, that the only thing we have refactored here is the little weather in London masthead. There's a lot of red on this page. This tells us that there's a lot of work left to do. This represents everything that is left to do. So these little visual health checks are a really nice way of getting a snapshot very quickly of the health or state of your refactoring code or refactored code base. After we've done this refactoring task, it should be a case of a simple find and replace for any class that starts with RF and just get rid of it. I say should be simple. Obviously, if we're doing a global find and replace, there's going to be a lot of manual testing overhead there. So just make sure, if RF is likely to collide with something, just pick a very unique string that's going to be very find and replaceable in your project. A little party trick for you now. I guess don't come to one of my parties. I'll just show you CSS. Refactoring specificity. So front-end developers, I'm sure we're all familiar with the specificity wars. If we're refactoring legacy CSS, there is every chance we're going to get a specificity collision. Old selectors using IDs or that are heavily nested are very likely to encroach on or regress new classes that we're writing. It's important to manage this stuff safely. We don't want to start loading the new style sheets with, or the newly refactored work with IDs or importance to get around this stuff. So we need to be able to hack specificity around, and we can actually do this quite effectively. If we take a real small snippet of HTML, just a simple link, there are 3 different hooks that we could style this via. We could style it via the A element, we could style it via the foo class, or by the bar ID. And if we do that, we're gonna find here that this link is going to be blue. CSS is very source order dependent. CSS is completely source order dependent. Whatever is found last is what gets applied, until you introduce specificity, at which point we can completely invert that paradigm. This is why specificity is such a problem in CSS. This is why it's very important to manage specificity properly. We have 3 very differently weighted selectors here, and they're all working against their natural source order. Now, we could use important to nudge these around to kind of artificially increase their prominence, but we shouldn't do that. Don't use important for never use important in anger, I always say. Always use important proactively. There is a time and place to use important, but this ain't it. We can hack specificity around before we lean on the important. These selectors now we haven't modified the HTML at all. We haven't once had to go into the view. We haven't had to nest something inside something else. But all of these selectors now have the exact same specificity. By writing IDs as attribute selectors, we can bring their specificity down to that of a class. The middle one has an element and class worth of specificity also. And the final one, what we're using here is the root pseudo selector to force a class worth of specificity into this selector. Now all of a sudden that link turns red. We've managed to hack specificity around in such a way that source order is now being maintained, and all of these selectors have the same specificity. I've pulled this out into a slightly more digestible slide. These all have the same specificity as each other now because IDs as attribute selectors have the specificity of one class. We can chain classes together with each other to increase their specificity. .foo will select a class of foo, but with double the amount of specificity. We don't have to write foo twice in the HTML, but we can write a selector like this, which is completely valid, it's in the spec, but it can increase specificity by double or triple. We can put 3 in a row. We could put 1 billion in a row to make it 1 billion times more specific. Side bit of trivia then. We could put 1 billion of these in a row and they will still never override the specificity of one ID. IDs are infinitely more specific than classes. 1 billion classes in a row will never override the specificity of one ID, except in Firefox, which the number is 256. Has anybody heard of Christian Heilmann? Anybody know Christian Heilmann? A few of us. When he used to work for Mozilla, I tweeted him about this problem. I said, hey, Chris, found this problem. 256 classes overrides an ID, and it should be an infinite number. And, is there a plan to fix this, or shall I open a bug? And in very Christian Heilmann fashion, he replied with, if you have to use 256 classes to get your CSS working, I would argue the fault is yours and not Firefox's. We aren't going to fix it. I was like, fair enough. So yeah, chaining classes with themselves increases their specificity by n times. And then finally, we can use the root pseudo selector in order to add a class worth of specificity. Any selector, any pseudo selector with a colon in it, so that's first child, last child, not, root, etc. These have one class worth of specificity. Has anybody heard of the root selector? People aware of that? Okay, about half of us. For those who haven't heard of it, the root selector is like a pointer, and it just points to the very top DOM node of your document. So in an SVG file, that would be the SVG tags. In an HTML file, that's the HTML tags. So it means that the root sort of node always exists. It's always there at runtime. It always exists. And we can target it just by using this root selector. Now, these are hacks. These are nasty. I'm not saying that these are good and we shouldn't start using IDs because we can hack them. These are hacks. These should be used defensively and sparingly. Ideally, we would refactor our CSS until we don't need any of these hacks. But I've never met a single developer who works in an ideal scenario. So we all fall into this middle one, right? Realistically, we're going to lean on one of these hacks. We're going to use one of these just to nudge specificity around, whilst also being aware that we are contributing to our technical debt. But never, again, please don't tweet this slide because I'll just get hated for like a week on Twitter if anyone. Never use important, right? This is causing a lot of heat at the moment. Never use important. It's got certain places in CSS, but hacking specificity around fixing legacy CSS problems, it's not the right thing to use. Use one of these hacks first. I'm going to have to start speeding up, I think. Shame.css. Anybody heard of shame.css before? Ah, cool, a few of us. Yeah, it's actually it's quite tasteless to quote yourself in a slide, but I did it. This is just a snippet from the article in which I kind of introduced the idea of shame.css. The idea of shame.css is you have a totally new style sheet reserved just for your hacky code. Code that you have to write to get a release out on time, but code that makes you ashamed nonetheless. It's just a dumping ground for all the nasty bits of CSS that you didn't want to write, but they had to exist. Now, me and my friend came up with this idea as a bit of a joke, but I actually implemented it on a lot of projects. And not that I write hacky CSS, it's for other people to use. I kid. We found that it was actually really useful to isolate your hacks. Hacks are inevitable, they're going to happen, but it's really important to signpost them. It makes everybody else aware that they exist and where they exist. Having all your CSS hacks in one file means that you don't have to search your code base for to-dos. That file is your to-do. That is your list of technical debt. That file is your self-writing to-do list. It makes it very easy to find and fix things. An example entry into shame.css could look something like this. You can see we're using the double selector hack to increase specificity because the promo A selector kept overriding the button styles. I'm increasing its specificity until I get a chance to refactor it. This comment is absolutely vital. I'm sure you've all come across a hacky bit of CSS before that's completely undocumented, and you don't know where is it used? Is it still used? Do I leave it alone? It's too weird to dare touching, so I'm just going to leave it alone. I've learned in my career that just by writing a little comment, you can get away with so much. Just describing why this exists tells the next developer that this doesn't affect me. I'm not working with the promo boxes at all today, so this doesn't affect me. And this becomes, like I say, your self-writing to-do list. Keeps good code nice and clean. Don't really have time to go into it, but Google the broken Windows theory. You can see which parts of the code base are problematic. It begins telling you which specific features are causing problems. It begins telling you that that responsive nav has just added 75 lines to the shame.css file. This is clearly a problem. We can literally start to get percentage values of how much of our project is hacky. This is good to take the product owners, project managers, designers, the business, and say, look, this feature that you had designed without my approval, that your client signed off on without me seeing it, it actually turned out to be really, really bad because it's just added 75 more lines to the project, the shame.css, which represents a 217% increase in hacks just for this one feature. Please, can we revisit it? And finally, it sounds quite Machiavellian, but it's easier to run git blame over one file than an entire project. This isn't necessarily to find bad developers. This isn't me trying to find people doing bad work. What this will actually tell you is, are there specific people struggling with specific aspects of the project? I found this really useful. I normally take a consultancy or lead role in UI projects, so I end up working with sort of junior through senior developers, and it helps me understand which knowledge gaps I have in my team. If there's one person contributing a lot of stuff around a certain feature, they just need a little more education, and that falls on my shoulders as the lead to provide that. So this isn't a case of shaming anyone, even though it's called shame.css. This git blame thing is just finding out who's struggling with what. Okay, I really have to finish up now. So the last thing I want to kind of go through is, I had a really interesting point of view kind of bestowed upon me 2 years ago. I was doing a workshop in England, and when I do a workshop, I go around and I ask everyone, you know, what's your name, what kind of stuff do you do, and blah, blah, blah. And usually you get the same, like, oh, I work at an agency, I'm a freelancer, I work on this application. But one guy said, I've only been a developer for 2 weeks now. I was a civil engineer, used to build roads and bridges, but I just had a complete change of heart. I wanted to change my career, and I decided to become a web developer, and that's why I'm on your workshop. I was like, that's amazing, like, congratulations, how are you finding the world of web development? And he said, well, I build roads and bridges for a living, and I don't really get to refactor that. I can't refactor my architecture. If I get a bridge wrong, 200 people die and I go to prison. Whereas as a web developer, I've realized that we can keep making changes. The more we learn about our system, the more we kind of see about how it's implemented, how it's used, how it evolves, we get the chance to go back and fix this. This is a second chance that a lot of industries don't get. For a very long time, I viewed refactoring as a completely awful, boring, tedious job. And it still kind of is, but it also represents this second chance. I can go back and fix my mistakes. For me now, refactoring is a case of saying, what would I have done differently first time around? Now I can do it. OK, so really, I'm starting to wrap up now. Remember that prevention is cheaper than the cure. Try and fix things as soon as they happen. Inflate your kind of estimates by half a day every time. You think it's going to take a day to build, tell your project manager a day and a half. Spend that half a day tidying stuff up. Technical debt is fine. It's a business decision. Just remember you have to keep up your repayments. Only refactor when you can see really tangible benefit to doing so. Avoid long refactoring tunnels, and isolate and highlight both your hacky code and your refactored code. You don't want people solving the same problem twice. The very, very last thing I want to leave you with, a guy called Sir Robert Baden-Powell, founder of the Scouting movement, famously told his Boy Scouts, always leave the campground cleaner than you found it. I think that we've kind of got a similar responsibility as developers to leave the project a little cleaner than we found it. Thank you very much for your time.